Welcome to Differentials Applied example number 1. All right, here's our problem. The side of a square measures 12 centimeters with a maximum possible error of 0.05 centimeters. A, find the maximum possible error in the area using differentials. B, find the maximum possible error by substituting into the formula for the area of a square. And C, find the percentage of error. So here's basically what's going on with this problem. We've got a manufacturer, somebody that's manufacturing us. We want a 12 centimeter by 12 centimeter square, but the manufacturer is guaranteeing that we'll get that 12 by 12 all the way up to, they've got a plus 0.5 centimeter tolerance on their manufacturing. So we'll get either a 12 by 12 or all the way up to potentially a 12.05 centimeter square. Okay, so we're going to break this down. We know that a square, the area is going to be side multiplied by a side. So an x times x or y times y, whatever. So we know that area is equal to, in this case, I've got it labeled side squared. So with the maximum possible error rate of 0.005, we could have anything from 12 centimeters all the way up to 12.05 centimeters. So we take the derivative of the area and we get dA ds is equal to 2s. We simply move the ds over on the equation. So dA is equal to 2s times the change of s. And we get the dA is equal to, or the maximum change in area is equal to 2 times 12 times 0.05, and we get a maximum change of area equal to 1.2 centimeters squared. That is using differentials. Okay, so to kind of prove that our differential is working, our calculus is working, we're going to do this old school and find the area of one extreme and then the area of the other extreme, and then subtract the two, and that gives you a maximum error or a maximum change. And that's what the part B is asking us to do in this question. So we've got our area at 12 centimeters squared, that's 144 centimeters squared. We've got our area at 12.5 centimeters, and that gives us an area of 145.203 centimeters squared, and we subtract those two and we see that we get almost the exact same answer that we had when we used calculus and we took the derivative and did the differential. So we've got a maximum error of 1.2025 centimeters squared, and that proves that our differential or our calculus way of doing it gives us essentially the same answer, or very, very close. Okay, so for the last part, part C, find the percentage of error. So you can interpret this a couple different ways. I originally looked at the percentage of error between using the differentials to calculate the area, or the dA and method, and then also using the old school method where you just found the area differences and subtracted the two areas from each other and found the differences. But that's not exactly what the answer in the back of the book is looking for. They're looking for the percentage of error of the area. And you can find that two different ways. You can find that with the differential mode, which would be the 1.2 centimeters, which would be the error, divided by the desired area, and that gives us the 0.833%, or you could take the old school calculated where you subtracted the two areas and found the difference, and that gives us the 0.835% of error for the area. Again, it looks like the answer in the back of the book, they're using the differential method to calculate the area error percent rate.